Hi everyone! So you will be going through this video to complete your notes for today. Sometimes I'm going to ask you to pause the video so that you can try things on your own before actually coming back here to look at the answers. And so that's actually what I'm going to do for this first one. So I want you to go through questions 1A, B, and this what do you notice? And then come back here to the video. So go ahead and pause this now. Okay, so hopefully you came back after trying this for yourself, but for question A, answers will vary. You just need to try that for yourself. And then this is for Michelle and her bike ride. So there's lots of things that you could have noticed. She starts at 6, she ends at 6, she turns around after 3 minutes. She starts 6 blocks away from something and ends there. Lots of different things. But this first thing is going to ask us to do piecewise function. So hopefully for your piecewise function, maybe the Pear Deck helped you, maybe you're still confused, but when you write a piecewise function, please remember that we need a piece for each part of the graph. So we're going to talk about the left side part first. So the left side piece is going to have a slope of -2, and it asks us to use the point 3, 0. So we'll have x minus 3. And this piece exists from when x is 0 to when x is 3. So from 0 to 3 minutes, that's the first piece. Then we have to look at the second piece, which is our right side, and write the equation for the right side. So that has a +2 slope, same point, x minus 3, and that exists from the 3rd minute until the 6th minute. Now, for the inequality signs, the 0-minute point and the 6-minute point do exist, so both of those should have equal to signs. And then that turning point, that 3, 0 point, is going to exist only on one of the equations. So you get to pick which one it goes under. So I'm going to pick the first one. So it's going to go in that first inequality for reference. Okay, so lots of things you could have noticed. But the big thing is about the fact that they're the same equations with different slopes. So we will be calling these linear absolute value functions. So that's right down here. So a few things are going to be true about these functions every single time we talk about an absolute value function and when we turn it into this piecewise function. So we're going to notice that they're actually, see that you have the same equations with different slopes. And when I say different, maybe I should put opposite with opposite slopes. Okay, we have V shapes every time. We have a nice vertical reflection. Sorry about that. Oops. So this is what those absolute value graphs should look like, and when we have the left side and the right side should look the same, just with opposite sign slopes. Okay, so moving on to page 2. So this is the next part where I want you to try on your own. What you're going to do is graph 2 different things. The first thing you're going to graph is f of x equals x, down here. And the way that you're going to graph that is just using the points -4 to 4. Then you're going to graph a second piece. You're going to graph g of x equals the absolute value of f of x, which is the same exact thing as just saying g of x equals the absolute value of x. Okay, you're going to put both of those things on your graph over here in part C. It will be helpful if you have different colors so you can see the difference between them, but if you don't, that's okay. So go ahead, pause this video, and try that on your own. Okay, so hopefully you came back, you filled this in, and you can see that my green is the f of x equals x, and my red is the absolute value of x. So what happens is that we have just a straight linear function when it's f of x equals x, but when we turn that into the absolute value, this piece right here is actually becoming this piece up at the top. So this difference occurs because you'll notice in this section here on my table that anytime I had negative values for x and an absolute value, they turn positive. So that should be happening every time. So every time we have absolute values, negative output values or negative values turn positive. In this case, so all my negative output values, put output, turned positive. So it created that reflection. Okay, it created this reflection. If you kind of use the x-axis as a line of symmetry, it created a reflection across the x-axis. Excuse me. So we took a linear function and turned it into an absolute value function. And that absolute value function can be written as a piecewise function, because if I pretended now, I'm going to extend this off. I'm going to extend this piecewise with arrows to make it continuous throughout the entire graph and not just -4 to 4 anymore. So if I wrote a piecewise for that, that is going to be the left-hand side is a negative slope, so it's going to be a negative x, and that exists from when x is less than 0. Then the right-hand side, so I'll highlight what I'm talking about. The right-hand side of the graph is when I have a positive x. That's when x is greater than 0. And then because the turning point is 0, 0, one of those has to be equal. This time I'm going to choose the second one. Okay, so anytime we have an absolute value, we can now split it up where our turning point exists into two pieces in a piecewise function. Okay, so they do end up becoming the same equations with opposite slopes. Okay, so what we just created is actually the parent function of an absolute value.